Hey everyone, this is Joe. I am the digital astronomer, and I want to thank you for tuning back into my channel. Today, we're going to look at a set of objects that often get overlooked in astrophotography. We're going to have fun with clusters. I hope you'll stay tuned. The first thing we need to do is to talk about what is a star cluster. When we say a star cluster, what we're talking about is a group of stars that are gravitationally bound together. And they come basically in two categories. The first are what we call globular clusters, and these remind us of a snowball when you look at them. They are a tightly packed group of maybe 100,000 or more stars, all in a very, very small area. The second are called open clusters, and these are still gravitationally bound, but they are much more spread out. And there we'll see up to a few hundred stars that make up the entire cluster. Let's take a look at a classic example of a globular cluster with the image that I took just a few nights ago. As an example of a globular cluster, I've chosen probably the most famous of all globs in the northern hemisphere, M13, the Great Star Cluster in Hercules. Now, if you're looking to find it, here is an easy way to do it. If you're looking towards the northeastern sky, find the constellation Hercules, outlined right here. And then if I zoom in, if you find these two shoulder stars and go about 1/3 of the way in between, you'll find M13, the Great Star Cluster in Hercules. Now, this picture that I've got here is not the first picture that I've ever taken of M13. In fact, if I go back almost 1 year to the date, this is one of the very first images that I ever took with the telescope. This also is M13. You can barely tell the resemblance. This is way too blue. The stars are out of focus and certainly was underexposed. Not a very good picture, but it was my first attempt. Here is my latest attempt. M13 is located approximately 25,000 light years away from Earth. 25,000 light years away from Earth, and it's approximately 145 light years in diameter. It was first observed in 1714 by Edmund Halley, of course, who's the comet is named after, and then later this was included in Charles Messier's catalog in 1764 in his catalog of things that are not comets. When they first looked at this, they had to observe it for a little while to make sure it wasn't a comet, because all they could see was sort of a faint, fuzzy patch. It wasn't until 1779 that William Herschel first began to resolve the individual stars that make up this cluster. If you look, if I zoom in just a little bit, you'll see how densely packed it is. Another feature that sort of pops out, I don't know how well you can see it, but there's a little X. This is often known as the propeller. And it's a feature that pops out when you are imaging it with a camera. Down to the bottom of the page, we see two little faint fuzzies. You may not be able to see the second one, but this first one right here is NGC 6207. That's a spiral galaxy. And listen to this. The globular cluster that we looked at a second ago is 25,000 light years away. This is 30 million light years away from Earth. It's a very small galaxy. Again, this was discovered in 1787 by William Herschel, but there's something even more faint and more interesting here. If I zoom up just a little bit and then zoom in, notice this little patch right here. You see where I'm circling? This little patch right here is IC 4617. When you're looking there, you're looking at an object that is 489 million light years away. That's incredible to me. In fact, I think this is probably the most distant object that I've ever been able to capture in my telescope so far. But that gives you an idea of the scope. When you're looking through these, here's the cluster, 25,000 light years away, 30 million light years away. Then over here, 489 million light years away. So that's a good example of what a globular cluster looks like. Now let's talk a little bit about open clusters. So M13 is a great example of a globular cluster, but now I want to turn our attention on to the second category of clusters, open clusters. This is M67, and you'll notice right away the difference. You don't have that tightly packed ball of stars. Instead, you have a few hundred, maybe a few thousand stars that make up the entire cluster. This is M67, and one of the things that's really interesting about this is the stars that make up the cluster, that are actually gravitationally bound together, are similar in size and mass to our own sun. In fact, many years ago, there was a theory that our own sun had been born in this cluster and migrated to its current location. That's pretty much been discouraged or discounted now, but it was a theory at some time, and this provides us a great opportunity to observe stars that are very much like our own. Another example of an open cluster is the Broken Heart Cluster. This is NGC 2281. And the reason it's called that is if you look here, you'll see kind of the shape of a heart. I'm outlining it there with my cursor. See, these are the two top parts of the heart. And then it looks like a line going down through, so it makes it look like a broken heart. Again, you have to use your imagination on these most of the time. Not the most spectacular image in the sky. This will not stop you dead when you're looking through it, but it's a rather interesting cluster. Again, these are gravitationally bound together stars, and they provide a great opportunity for us to image something when there's a full moon out. This image was taken during a full moon and still came out pretty good. Perhaps the most well-known open cluster are the Pleiades, M45. Now, even if you don't have a telescope or a pair of binoculars, the Pleiades are generally in the fall and winter visible with the naked eye. In fact, I'll never forget the first time that I saw the Pleiades. I was out with my telescope when I was about 12 or 13 years old. I noticed this faint fuzzy patch in the sky. Couldn't figure out what it was, couldn't get my telescope to focus on it, but I got a pair of binoculars out, and you cannot see with binoculars the nebulosity that shows up in this image, but you can see these very incredibly bright blue stars. And they get their blue haze, by the way, from this nebulosity. And again, this is a great example of an open cluster. These are all gravitationally bound together stars, and they have the fortune of having this nebulosity. Astronomers still debate whether or not these stars were born out of this gas. In other words, this gas is the leftover remnants from the beginning of these stars, or whether this just happens to be some gas that's floating between our vantage point and the particular stars that we're looking at. You can study that and decide what you want to with it, but I think this is an incredible object and is one of the things that just reminds you of how incredibly beautiful the night sky is. Well, that's fun with clusters. I hope you enjoyed it. And if you did, I hope you'll subscribe to my channel and then share it with other people to get the word out. Next week, we're going to have another exciting episode. I hope you'll tune back in. If you enjoy my videos, please support me by clicking on like, subscribe, and share. Thank you.